Hi, a warm welcome to you all who join us today from all over the world. I'm Tyler, and I'm a developer relations engineer on the Earth Engine team, and I'm going to be your host for today's event. So on behalf of the team, I'd like to welcome you all to the apps edition of Hey, Earth Engine, how do I? And today is going to be a live stream event where you can share your questions and we will attempt to solve them, or at least point you in the right direction. And I hope that you've had a chance to already attend some of our trainings in the past, especially the Earth Engine apps training that we did recently called Publishing an Earth Engine App to Accompany Your Research Paper. If you haven't seen that training or others, you can watch it on demand by going back to earthoutreachonair.withgoogle.com and click on the Earth Engine tab to find this and other previously recorded trainings. So today we're going to focus on answering questions that you have related to Earth Engine apps. We can answer questions that are conceptual in relation to Earth Engine apps. We can talk about and possibly demonstrate how to build specific functionality into your app, like an legend, which we all know is a very popular request, and help you just debug your app scripts when you run into problems. If you're doing this, make sure that whatever you're sharing with us, you've made all the resources and assets accessible so that we can be able to effectively help you. But basically, we're here to help you figure out how to create great apps by answering questions. But before I introduce all the rest of the experts on apps that are going to be answering questions, let me show you how you can actually send us your questions. First off, you can write your question in the Q&A section below this video on this page if you're watching this live. If you want to ask a question of a specific speaker, please mention their name when you're typing in your question. And if you see a question already in the Q&A that you think you would like to know the answer to, upvote it using the like button so we can know how to prioritize the questions that have been asked. So we're starting to monitor the Q&A questions starting now, so feel free to start submitting and upvoting questions. A reminder that the topic and focus for this event is Earth Engine apps, so please ask us questions relevant to that. Those are the ones that we're going to be selecting. And there will be other chances in the future for you to ask other questions related to Earth Engine on other aspects of Earth Engine. All right, so let's meet our team of app experts who are going to be answering questions today. Hello there, team. We have Michael, Justin, Sufi here today that will be answering questions. All right, do you remember the icebreakers that we did during the last Ask Me Anything event? In the spirit of the theme, we're going to do an app-specific kind of icebreaker questions to kick things off. So the first question I have is for Justin. Justin, can you talk about or show us one cool thing that can be done with Earth Engine apps that not a lot of users are going to know about? And when you're kicking this off too, don't forget to introduce yourself.
Sure. Hi, everyone. I'm Justin Broughton, a developer relations engineer with the Earth Engine team. Man, it's hard to pick just one cool thing that people might not know about. But here's an idea. How about an image chip gallery? So if you're familiar with Sentinel Hub's EO browser or USGS's Earth Explorer, you might be familiar with a chip gallery where it shows you a sample of images for a given date range and region. And you can do a similar thing with Earth Engine apps. Dusty, do you mind switching over to my screen? Okay, so here I have an app with a image chip gallery on the left here, or excuse me, on the right. And what this is doing is taking an image collection, and for a region, it is making a thumbnail image and appending it to this this panel. So this is a cool thing if you're interested in time series and identifying change. This is showing a forest clear cut. We can see that in 2014, this section of land was cut and then it has regrown. So this is kind of a cool feature if you're interested in exploring in time series data. I'll share the link to this app in the resources doc so you can explore this on your own. It also provides a link to the source code so you can code this up yourself.
Great, thanks, Justin. That's a pretty good example of an advanced app. Next up, we'll have Michael. Michael, can you talk to us about the most fun Earth Engine app that you've ever built?
Sure thing, yeah. First, I just want to welcome everybody. I'm Michael. I'm an engineer on the Earth Engine team. I've been on the Earth Engine team for a while. I've worn a lot of different hats, going all the way from the back end, sort of more core computation infrastructure, engineering there, to I was one of the first people who worked on the Earth Engine apps infrastructure. So excited to have everyone's questions. Please do pepper questions in the chat. Yeah, the most fun app I've built. I try not to build fun apps in particular. The most fun I've had building an app was definitely, Dusty, I don't know if you can share my screen. This one for the Global Intertidal Change paper. This is a paper I was a contributor on. I just love the color palette. It's a super simple, just interactive exploration app. But I had a lot of fun building sort of the sister app here, which is a data download app. So I went, and I'll share links to these. But this is super simple. All it's doing is, and I'll try to make this screen a little, hopefully that all fits. This lets you download tiles from that data set. So this was a scientific publication, and these are just references to files in Google Cloud Storage. Not a ton of Earth Engine happening here other than to draw the grid, render it, provide an interface for exploration. I just really like this because it shows kind of the end-to-end. You can look at the data live in Earth Engine, interact with them, but also route folks to downloads in the platform. So that's the most fun I've had.
Thanks. That's a great example. Actually, it's quite near to my interests of trying to get published research into the hands of more people, get the data and results more accessible. All right, so thanks, Michael. Next up, we have Sufi. And Sufi, this is your first Hey Earth Engine event.
Yes, it is.
Yeah, can you talk about yourself and your role with apps?
Yeah, I'm super excited to be here. Yeah, my name is Sufyan. You can call me Sufi. I've been on the Earth Engine team for about 2 years now, working on front end. And my first project on Earth Engine was actually working on that rectangle drawing tool and the drawing tools API. And so then, and currently I work a lot on the JavaScript client, and I also kind of work on improving the code editor front end. So please ask me questions about the drawing tools API or the JavaScript client libraries.
Great. All right, so let's put a wrap there on the icebreakers, and let's see if we have questions that are trickling in. As a reminder that you can be answering or asking questions at the bottom of the screen if you're watching this live, and we will order them according to how well we think that we can answer them. But to start off, while people are asking questions, I'm going to ask one that has been commonly asked on like the developers group or when we go and teach people about apps. But it is how the URL parameters work, that you can actually pass information to an app through putting a parameter in the URL string that you type into a browser. So who would like to take a crack at answering that? Justin, can I interest you?
Sure. So URL parameters are a relatively new feature of Earth Engine, and I think you can do a lot of things with them, but what I like to use them for is app state preservation, so that, you know, if you have looked at a region in an app and you've found something that's cool and you want to share it with a colleague, instead of like, you know, typing in an email, go to this Latin long and set these parameters, and then you'll see what I'm talking about. Instead of doing that, you can set URL parameters so that when you've zoomed into a region and you have selected certain things from drop-down menus, all of those options and the extent of the browse of the map have been saved in URL parameters. So when you share the URL, they'll see exactly what you see. And so I'll just show a really quick demo here. Dusty, if you could switch to my screen of how these work. So what I've got here is a little bit of setup. So this is just going to show a map of wildfires from August of 2020. And so I'm going to run this just to show you what we're looking at. And so if you were to just run this app and share it with somebody, this is what they would see. But say you were interested in the CZU fire, and you thought there was something neat about this and you wanted to share it with a colleague. And so you were zoomed in onto this and you wanted to share it. That would be difficult, to say in an email. So what we can do is we can add in URL parameters to save this map extent. Like what you're looking at in the map will be what they see. So what we need to do is have a function that like initializes the app. When the app loads, it will know where to place the map position. So what I've written here is a function map initialize, and what we have here are 3 get calls. So this is the UI.url.get, and what it does is it will look for this longitude, latitude, and zoom parameter in the URL. And if you look right now, you probably can't see because it's small, but there are no parameters. This is just the typical Earth Engine URL. And so when you call these and it's looking for long, lat, and zoom, if it can't find them, it's going to revert to a default. So I'm giving it a default here to center on like the Western United States. And then once it's fetched these values from the URL or as default, we're saving them as variables, and then we are setting the map, based on whatever it found in the URL or the defaults. So then if we run this, we can see that nothing has happened yet. All that it's done is it has used our defaults because there's nothing in the URL parameters for it to fetch. And so as we're like moving around, nothing is changing in the URL, if you notice. So what we need to do is also implement set. So URL has a get and a set. So I've got another function here that will run. It will be called anytime there's a change on the map bounds. And so what it's doing is anytime there's a change on the map bounds, this function gets run. And what it's doing is it is setting the URL parameters for long, lat, and zoom based on whatever the extent of the map is. So if I run this now, this callback function has been registered to this on change bounds event for the map. So now you can see if I'm zooming in and moving around, keep an eye on the URL, and hopefully you'll notice that it's changing. And so if I copy this URL now and enter it in a new tab, oh, sorry, hold on, go back here. I need to get the link. And keep in mind that this isn't a published app, but the same functionality works when you publish your app. This is just a development environment for the app. So now the app, we're looking at what was saved previously.
To underscore Justin's point, this basically allows you to save a dictionary of what at the end of the day are strings in the URL parameter, in the URL. So URLs, just like as a matter of the web, have a part of them that kind of doesn't matter for navigation to the page. It comes after the little hash there. And so what we're doing is we're saving kind of like local information for the page in that hash part of the URL. And so this lets you have keyed values, so keys and values that let you store some small amount of data. Rough order of magnitude, you can think about saving like thousands of characters there. So you wouldn't want to save like, you wouldn't want to try to save gigabytes of data there. But if you have configuration parameters like, for example, longitude, latitude, zoom, or some saved values that would go into managing your application state, whether you're showing a side panel, all those can just be saved as strings on the URL. And it's pretty easy to, as Justin's showing here, set and get things. I want to really quickly just share my screen. We had a Medium blog post about this feature on the Google Earth Medium blog. And so in here, this was we view it as kind of like an app development workflow. It helps just kind of speed things up because you don't have to write a bunch of custom logic yourself. So here are links to some examples. We'll put these in the references that we'll share out. I just wanted to call everyone's attention to this particular post because it's useful and it has some nice demos that are very much aligned with what Justin's showing here.
Thanks, Michael.
You can steal the screen back.
Thanks, Justin and Michael. I think we'll move on to the next question that we have. And we actually saw a little example of this already, but a very common question is how to write the logic that a widget triggers, like a callback, an event handler. So who would like to answer that? What are best practices for these things of callbacks? And first off, what are these callbacks?
Yeah, I can take that one. So yeah, what are callbacks, right? If you think about like the bread and butter of Earth Engine apps, we have the widgets, which are the user interface components that users are interacting with. And then you have like the callbacks. And that's kind of, I feel like that's kind of the hardest thing to kind of wrap your head around, especially for me as like a front-end engineer, and why callbacks are so hard to work with. And so if you think about it, the hard part about user interface components are that you don't know when the user is going to click a button or click on a map or select something in a dropdown. And so the thing is you need to write some sort of code which will listen for, and another word for callbacks, we call it event handling. That means is when the user is interacting with that user interface component, you need to write some code in such a way that some function is run when the user has finished, interacting. And then in some sense, we're kind of notifying you, the app developer, hey, the user did something. Now you can go and work with it. And so I can kind of show you a little bit, like we can kind of like work our way up to kind of more complicated examples. But like the simplest example of a callback is just like button on click. So let's just take a look at that. Let me just. So I'm just gonna add a button. Actually, I'm just gonna just print a button to this console. Button. And so the simplest thing, okay, I didn't even add any text there, so I'll just say click me. All right, so the simplest thing we can do is just add a on click event handler. And so the input to this is a function which will run whenever something is clicked. So I'm just going to print I was clicked.
Sufi, can I ask you to increase the size of your?
Yeah, of course.
Thanks.
First, there it is. So when I press click, click me, we call this function. So that's the simplest one. But what if you want to pull data from the thing that, or the event that happened? So the next kind of event handler would be like something like map.onClick. So let's just see what happens when I pass. Okay, let's just do the same sort of event handler. I'll click on the map, and I still get I was clicked. And the interesting thing we can do, for example, is say var print me can be the function. I'm just gonna show you this little thing here. The interesting thing we can do here is we can pass in the name of a function into the click handlers, and the same thing will happen. Okay, but let me go back to my point. So I want this map to give me information about the latitude and longitude, just like Justin was showing in his URL params. So the inputs to the function will be the information about the data. So, like for example, let me go back to writing a function here. The first parameter is going to be like something, but it's going to be the latitude, longitude. Let's go ahead and print that. So I'm going to click on the map, and I actually get data. So in general, you can think about these callbacks as a notification to you, the developer, that the user has interacted with something, and then actually pass in some information about what was passed in. So like, for example, a text box will pass in text information about what the user has typed in, or the drop-down select will tell you which select item was chosen. So, so just to finally round off the question, how do you write good ones, right? And that's kind of more of a philosophical question. And so to answer that, I think the best way to write good callbacks is to compartmentalize your code in the best way possible. So what do I mean by that? So there are kind of two ways to compartmentalize. That means to like package up your logic together into like a succinct package. Okay, for example, the easiest thing, the first way is to have a very simple callback. So like this, for example, a very simple callback like print something or toggle a map layer or draw a map layer on the screen. There's kind of just like if X, do Y. But another way to think about compartmentalizing your app logic is, for example, let's say when like a user clicks a check on a checkbox, you need a lot of things to happen on the screen. Like, for example, you need to change the text somewhere. You need to toggle a map layer. You need to change the items in text box. What you'll want to do is you'll want to write like a refresh function. And you'll want to consolidate all of your kind of logic, which has to do with like changing things on the screen, like button dot set value, I think. Yeah. Like I was clicked. And maybe you want to change something about the map. So map dot, whatever. And what we'll do is every single time we run a callback, we're just going to call this refresh function. So let's just see if I wrote my code correctly. So when I click the button, oh, I have a bug. Sorry. How do I change the set label? Hey, I know how to write good things in code. There we go. I was clicked. So the idea is whenever anything is happening on the screen, we're always going to call this refresh function, and it's going to go in there and actually look at some of the values that are there on this on the different widgets. Maybe you'll look at items that are kind of data that's coming from other places, and then updating the relevant fields or the relevant user interface. So those are kind of two ways to write callbacks: simple or these kind of more complicated refresh function. But I think I've been talking for too long, so I'll pass the mic to the next person.
Just really quick, Sufi, I think you touched on a really important point, and one that maybe we should do a better job communicating in the docs. Callbacks you can really think about as being kind of event handlers. So they're packaged up pieces of logic that just allow you to react to events that you otherwise had no way of kind of predicting. So like an example of that is these clicks. Like you as the app developer don't know when someone is going to click on a button or click on the map. All you can do is specify kind of the logic for handling and reacting to those events. So that's compartmentalizing that logic, just like you said, packaging it up in a way that's repeatable and makes it very clear what are the actions that are going to happen. So a good example is this map on click. It's very clear that it does a small thing and then it refreshes the page or refreshes the UI here. So yeah, +1, that's all super useful. And this is this tends to be the hardest thing, the sort of mental block to get past when developing apps. This is definitely what I would consider the hardest part to learn. in terms of just it's a new way of thinking about passing functions as kind of data. And there's a bit of there's an aha moment that has to happen. But once it does, it becomes very, very powerful. It's a super useful tool to write apps.
Absolutely. And I think the most interesting thing about our callbacks is, well, if you look at like any of these, any of these arguments like on click, but let's take a look at, like, for example, like the select, which is like a drop down. Just find it. My screen got big, so I have to find it. For example, on change. So it'll tell you what gets passed through. So for example, this function says the currently selected value, so like some string, but then it will also supply the widget itself. So there's actually some interesting interplay here about where you can actually know what widget had actually fired that that callback, because you can actually look at the widget that gets returned. So that's something that you can kind of explore or mess around with.
Sufi, you just touched on a question I had. I was curious how a person would know what data is passed from an event. So I see, like in your on-click example, the variable you've written there is lat long. I think you must have known, what you were getting. But if you didn't know, how would you find out?
Oh, great question. Sorry for the echoes. I'm not sure where that's coming from. So yeah, so what's actually a great way to? I always just print all my callbacks. I use print as a callback, in fact. So then what I do is I say like map.onClick, and I just write print. And that's like literally the print function. Again, it's like the print that you usually use, but it's a function, so it's a callback as well. It can be used as a callback. So then when I hit run, I'm gonna go ahead and actually let me remove this one. I'll hit run again, and then I press click, and then I got two things: this object, lat long, and then you have this error message. Which says component already rendered. So actually, yeah, that's because the callback returned the map itself, and it tried to render the map on the console. So you can actually get some clues about what's returned in the callback just by using print as a callback as well. I'm gonna put on some headphones. I think it'll help reduce the echoing problem. Give me 1 second.
Great. Well, I'll just add a few extra things there. If you want to learn more about events from the docs, there is a page that just search for in the Earth Engine docs called Events that will give you more of the details of how events work, and a lot of the other event handling examples are there as well. Also, I mentioned at the beginning of this event that there was a recently published event called Publishing an Earth Engine App for Your Research Paper. There's lots of examples in there of writing callbacks. And I guess the final reminder I have, because I'm looking at who is sending in questions, is make sure that your questions for this event are related to Earth Engine apps. We're getting lots of great questions, but they're much broader than Earth Engine apps, and we're definitely trying to focus primarily on Earth Engine apps. So I encourage you to still keep asking questions there, especially the Earth Engine apps related ones. All right, so let's move on to a next question that we have, and it's a very common one. How can I add a legend to my app, or actually to anything in the code editor? Who wants to take that one?
I can give that one a shot.
All right.
So we don't have a built-in legend, but that means that there's a lot of flexibility for you to build your own. I think it would be nice to have sort of a standard legend feature. But what we can do right now is build them from UI labels, UI thumbnail, and UI panels. And Dusty, if you could switch over to my screen, please. And we have a few examples in the Earth Engine docs and in the code editor examples. This is just a recent one from an event that Tyler and I did. that sort of breaks up the legend logic into 3 different sections. So what we're seeing here is all of the widgets that go into composing a legend. So you can see down here in the bottom of my screen, this is the legend that we're building. So we have a title or a label to tell people what they are looking at. We have a gradient color bar that matches the scale of the map data. And then we have some value reference points along the gradient bar. And so what we have here is a panel to hold all of this. And I've called that, in this case, this legend panel. It's a UI panel. And I'm filling it up with all of the other components. So I have this title, which is a UI label. This gradient bar is a UI thumbnail. It is a representation of an EE.image, which is longitude, and we have just applied the color gradient to a chunk of longitude, a gradient of longitude values, and then the values at the bottom are UI labels. And right, so we just define all these components individually, and then we need to style them. So we've got a style section down here. And this is kind of quite long for the legend section, and I won't go into a lot of detail about it. But sort of for each of these widgets that's composing the legend, it has some unique styling, for how big I want to make the legend, the font size, so forth. And then in this case, we have the legend updating when a user selects a new band. So right now we're looking at annual forb and grass, but we could have the user select bare ground, and we want to update the legend. And so this is happening via an event handler. We've just been talking about these functions that you write that are fired off when an event happens. And so there's some logic to re-render the legend based on whatever the app's state is. And I guess if I can find this quick enough here, I think it's update legend. So this third component is being able to update the legend sort of dynamically. And so what we're doing is we are resetting the value for our label. So now, it's a new land cover class that we're looking at. So we want to update the label. We're also having to change what the color palette is based on whatever band was selected. And then we have to update the value along the color gradient. So yeah, there's not a standard way, there's not a standard function for developing legends, but we certainly have the capability to do it. You just have to kind of put it together yourself. So I'll share this example in the resources, and there's also a good example, maybe I think Michael put together on ocean temperature, and that's available through the code editor examples. Maybe anybody else has anything to say on legends?
All right, thanks, Justin, for that. I think the next we're going to go to a question that was submitted at the bottom of the event page. So let me dive into that. It is a drawing tools related one, so listen up, Sufi. Is it possible to disable or hide the plus new layer functionality on drawing tools so that users can only add programmatically with predefined names?
That would be a great feature for us to have. Unfortunately, we do not have that specific functionality of like turning off the new layer mode. However, there are some workarounds that you could potentially do. And that requires maybe doing a little bit of kind of writing your own drawing tools UI. And that's kind of a lot to ask, but I wanted to first prove that you can do that. So what I did when I was running or writing the drawing tools API, I wanted to know, could I rewrite the entire drawing tools API in the code editor and just hide the existing one. And you can do that. So let me show you just quickly in general how to work with the Drawing Tools API. This is, so let me just quickly show you. If you want to get the drawing tools, so you can just call like map.drawingtools, and that will get you the drawing tools. Let me just show you quickly, if you just type in the drawing tools, then you'll actually see, here is the drawing tools API, and there's a lot of callbacks in here. As you can tell, there's a lot of functions methods where the first parameter is callback. And so one of them is set shown. So you can say set shown false. So that's the thing that's the method that you want to use to just remove the drawing tools altogether. And then on the other side, what you do is you actually use, for example, so after you've hidden your drawing tools, you can actually then create a layer in drawing tools. Actually, let me just go ahead and reset so we can just kind of look at this a little fresh. So, so map.drawingTools to get the drawing tools. Then drawing tools set shown false to get rid of it. Let me just make sure that works. And then the next thing to do is now listen for layers being added. Or actually, let's pre-populate our drawing tools with a layer. So what we could do is we can say add layer. So we can just say drawing tools add layer, and the geometries that we're gonna input is just nothing, because we're gonna assume that we're gonna start with a blank layer, and a name, which is gonna say like something, or let's just say geometries. Okay, that's fine. So I will actually comment this out so we can see what's going on. So now we do actually have a geometries layer. Actually, let me just go ahead and delete these. I think they were here from before. I delete them by just pressing that gear icon. So one more time, I press run, add layer, that adds the layer. When I run it again, we'll actually get the layer again. So that's just something to take into consideration. So instead, what we could do is after the layer is created, we could just say var layer equals drawing tools dot layers to get all the layers dot get 0 to get the first one. So let me just print that just to show that. So, and then from there, you actually need to do a little bit of UI stuff, or kind of work on some callbacks here. So for example, we can do layer. So like, for example, we want to listen for on draw. So whenever the user is drawing anything, it's gonna be going into this layer, and we want to just keep track of that. So for example, drawing tools dot on draw, and then in this callback, maybe what we want to do is, obviously, for now we can just go ahead and print whatever is returned back from here. So we get the geometry, the layer, and the drawing tools itself. So like geometry. So here we can let's go ahead and print the geometry just to show that something's happening. So when I'm gonna draw something here, and we get the geometry, so we can use that. And then to build the UI, it starts to get a little more complicated. But what you then do is, you essentially just create a panel, and some buttons on that panel, and kind of bind some of the functionality to drawing to that. I think Justin has actually a pretty good example of how to just get like the specific drawing tools. But let me actually just go and go back and show you the bigger example. And the best thing we can do here is I'll go ahead and share this code with you so that you can actually use it as like a module in your code, and then you can actually just use this UI, which I've conveniently created, and you can kind of get rid of some of the features you don't want from here. But yeah, I hope that kind of answers at least some of the basic questions. But to get more complicated, it does require you to get a little bit more deeper into building the UI with labels and clever styling.
Excellent. Well, thanks for that tour. And will you be able to share the full example of recreating the drawing tools? Okay, so script, cool. So that people who are interested in that can actually look at the example code in detail. All right, for our next question, this is a good one. Okay, so when you're building an Earth Engine app, one of the things that you lose is some of the features of the code editor, like the inspector. So this question is, how can I replicate the inspector functionality of the code editor in my Earth Engine app itself? Michael, would you like to start on that one?
Absolutely, yes. Yeah, we shared a bit of this in an earlier Earth Engine How Do I, but which is why I'm so excited to answer. I already have code. So if we could share my screen, I'll share out this example. Super simple. All it's
all right, we had Michael disappear for a second, and he's back. All right.
Am I back? Can you hear me? Yes.
Yep, I can hear you and then see your screen.
Excellent. So this is a short script. It's 25 lines with plenty of comments peppered in. Essentially, so just backing way up, in the code editor, we have this inspector tab. And so when you click this inspector tab, it does a couple things. It changes your mouse to a crosshair. So your cursor becomes a crosshair and lets you, when you click, inspect values on the map. So it prints out, if you don't have any data added, it will just print out, for example, like longitude and latitude. Here, if I do something like, let me just erase the rest of this code really quick. If I just have a data layer on the map, you can see there's a beautiful visualization. I haven't gone through and built, for example, a legend. So if I want to know what these values are, I can use the code editor inspector to click through and extract values. So here we see that this is just an SRTM layer, the elevation data set. And as we click around, we get interactive values that are being fetched from Earth Engine from the server and printed. So what this example does is it adds a label to the map. So in apps, you can kind of think about it's like you only have the bottom half of the code editor. What's happening here is that we add this label to the bottom half. So this gives us, this is the place that we actually get the output, get the return values. So our goal here is to build that inspector functionality. The way we do that is exactly the same way that we talked about before, like binding together these handlers, binding together these callbacks, and it's pretty straightforward. So I just have a function here that updates the label, and I did this just to reduce the amount of like repeated code that I have in a couple places. So this is just, again, trying to package up a small piece of functionality. So given an elevation, which is a number, update it and set, put it inside of a string and set the value on the label itself. So that function does it. We're just declaring the function there. Next, we define a click handler. So this is when I click on the map, this is the behavior that I want to have happen. We can see if I just search through map on click, I'll say on click, and you can see that there are a bunch of different on-click functions for different types of widgets. Here, this is one of the map callbacks. So it accepts the callback, the event handler, and will pass it the object containing the coordinates of the click point. So with keys, lon, and lat. So that's exactly what I'm handling here. Is take the click, extract the click longitude and latitude, and we have to remember these are JavaScript. Like this is a JavaScript event. Everything is happening in the page, so we'll refer to that as like client-side logic. So we extract the longitude and latitude, we put them in a server-side point. So this, everything with EE dot is server-side. And then we'll sample the image on the server. So what we're doing is we're taking the image, we call the sample function with that point. Because sample can return many values, it can sample a collection or sample multiple bands. Here, what we're interested in is just elevation. So we set the value to be loading, and then we call evaluate. And there's, you might be saying, why don't we just call update label directly? This is another kind of tricky part, but it's fundamental to building Earth Engine apps that are performant and useful. So if you don't want, if you write applications and you're finding that they're hanging or they're pausing the browser or they're really slow, often it's because the wiring is not quite correct in terms of how you're passing data around and in particular places that you're waiting. So let me dig into that a little bit. Set value loading, it's pretty straightforward. So when we click, you'll see maybe, depending on how fast we get responses back, there's this loading operation. So this is what happens when we're waiting for data to come back from the server. So we set this label to be loading on click, and then we call this evaluate function. Evaluate is if you've used like get info to request data from the Earth Engine servers, you're basically saying, take this sample value, send this expression to the server, get results back, and then once I have the results, call this callback function. So asynchronously trigger the label update. Why that's useful? So asynchronicity, being able to do things sort of in an unpredictable timing and unpredictable order, is actually really useful for performance. What this lets us express, or what we're expressing here, is we want to send the request to the server and continue doing other things while we wait for the response. When we get the response, this is how we'll handle it. So in the same way that we don't know when the user will click on the map in our app, we also don't necessarily know when the server will respond. So rather than sitting and waiting for it, like we would use with a get info, evaluate lets us do that. It almost feels like another level of indirection or layer of indirection. But this will let us send the response and then handle it on the client. The important thing to note here is that, and I called out in the comment here, the result we get back is actually a JavaScript value. So we have a client side. This is the result of server-side processing. It's sent back to the client. And here, because we're just doing getting the first value and extracting the elevation value, we're just getting a number back, and that passes right into our update label. So I'll demo it again. Have the brief loading. We don't have to unset the loading explicitly because that's what's done with update label when that's triggered. And then just to make it complete, I set so I wire all these together. I add the label to the map. I say, this is the on-click functionality I want. And then we change the cursor to a crosshair. All of this you can look at. I'll share this link. The documentation in the code editor is pretty useful here. So if you're interested in, what are the other options for cursors, for example, you can just crack into the documentation. And yeah, today it's crosshair or the hand. Feature requests welcome. But yeah, that's the example. We'll put this in the resources. Happy to field any more questions about this type of logic. And also, please note this is a jumping off point, right? So if I wanted to have a super sophisticated, do a reduction and get some, what's the average of values in a 15 by 15 pixel region, or sky's the limit in terms of different computation that you want to express in this framework. That's what I got.
Thanks, Michael. Do you mind if I add, I had the opportunity recently to code up an inspector for a point feature collection. So in Michael's example, it was inspecting an image, but you might have a feature collection as well. And this was kind of an interesting example. Dusty, could you share my screen real quick? Thanks. I won't spend much time on this, just to demo it really quick and point you to a link in our resources. But here we have a point feature collection, and if you wanted to get the information, the properties for one of these points, you can click and you can see that it's displayed in a panel. And so basically all it's doing is it's finding the nearest point to where you clicked, and then it is looping through all of the properties of that feature and kind of concatenating them in a long string, and then setting it into this label. So that's kind of a cool thing to do as well. So I'll share that link in the resources.
Excellent. Thanks. Looking back at the questions, I guess we have a follow on for Sufi in related to the drawing tools. Can you use this drawing tools hack to allow app users to export drawn geometries as Google Drive files? And it might be helpful to just talk about exporting functionality and limitations in general for Earth Engine apps.
Yeah, of course. Thank you for the question. Yeah, so just to be clear, yeah, so all of the drawing tools API is available in apps. Pretty much, it's the same deal with all apps. Like what you see, below the fold is what you get on the other side when you go to publish. And I also wanted to, and now that I remember, I wrote a community tutorial a while back on the drawing tools API. So let me just show you where you can find that under community and drawing tools. And I kind of go through some of the basics of how to use drawing tools. And then I also, I think there's one bit of functionality which is interesting about, when you're thinking about exporting, or rather collecting information, which is I also provided a 2-feature collection API, which lets you, or actually no, so the other way to do it is for each layer, you can call get EE object, and get EE object will return, like, if you have a geometry, then it's a geometry. If it's a feature collection, then it'll become a feature collection. So because you can kind of set the properties on the like when you go into the geometry layer list and then you click on that gear icon, you can kind of change like a geometry layer to like a geometry or a feature collection. So get EE object returns like the EE object related to the geometries, so that it's just an easier way to like get the data out of your geometry. But the second part of the question is interesting, right? Because what you really want to do, right, is like, let's say, for example, in this scenario, you're trying to build a classification app. So this is kind of the demo that is displayed here, where you want your users to go in there, be able to like pick points for certain classification modes, and then you want to be able to like export them and get them out of apps. So the thing is in general, exports do not work in apps, and the reason why is we want to make sure that, like, for example, like something that we didn't really quite explain earlier was that your Earth Engine apps, the user that is using the Earth Engine app is actually a service account that we create after you hit publish. And that's a user that essentially is running your Earth Engine company. But that user doesn't actually have permission to do any export jobs. It's only really allowed to really get it can only really fetch map tiles and do kind of the Earth Engine expression stuff. So in general, exports are disallowed in apps, and that just makes sure that we don't clog up your task queue. Like if someone wanted to build like 1 billion tasks on your task queue, we don't necessarily want that to happen. The other thing though, and that there's actually another way to get feature collection data out, is you could potentially use, I think there's Git table download. Does that work? Can anyone jump in and
Yes.
let me know if that's even possible? Like, for example, what I could do is oh yeah, get download URL. So like, let's say, for example, I have my feature collection. I can maybe call get download URL, get the URL, and then display it in a label. I think that might be possible. So then after the user has finished drawing, you call get EE object on the geometry layer to get like the feature collection associated with that layer. And then what you can do is then you can call feature collection get download URL, and then specify the format. So that will turn you'll want to supply the callback. Supply the callback, get the URL as a string, and then just print that in a UI label. But why don't someone jump in and tell me if that's even possible, and then I could try coding it up as we go.
Yeah, definitely can confirm. So those functions they're not, we don't think about them as exports. They don't use the Earth Engine batch export system, which is good because it means you can use them in apps. It is less good because it means that really they don't have the scale of the Earth Engine batch processing system behind them. So what that translates into is you can only do a small amount of computation. And when we say small, order minutes and megabytes rather than days and terabytes that you can access via the batch system. So there are two related functions there. Feature collection get download URL. So that gives you a download URL for the feature collection. That's what it says on the tin. What's happening there is basically it lets you extract, I think, and this is where I need to be corrected. I think it lets you download it as KML, CSV, or JSON. So you can just extract your information as one of those formats. It's just a kind of traditional, like, get the file as a download. You can, there are three functions actually. So that's for feature collections. For image collections, we have, for images, we have a similar get download URL, which provides a TIFF. So that lets you extract a TIFF file, which it actually is a zip of individual bands, because Earth Engine bands can have their own projections. Getting a little echo. I don't know if that's me. The third option is thank you to whoever did that. The third option is for images. We can also get thumb URLs, and maybe there's a fourth. I'm remembering more and more. We can get thumbnail URLs as well as film strip URLs. So the two options there are these are, instead of getting like a file that you download, these are things that the browser actually understands. So the browser can display a thumbnail. It can display just any of the thumbnail formats, which are like JPEG or PNG. For image collections, you can say get a film strip URL, which is just like calling multiple get thumbnail URLs. But what this does is it's analogous to a strip of film. It just lays the images one on top of another, so it chains them together. So if I have 10 images in my collection and I select a region and I say image collection dot get film strip URL, I'm able to express, or able to download and view all of those things together. That's particularly useful for building just like Explorer apps, but also when you're building applications that are sort of more complex than Earth Engine apps. So if you're building like a standalone web page, or you're actually doing the application development for something like an App Engine app or a standalone JavaScript website, That is useful because it lets you fetch multiple chips at once. So this can power the kind of speedier version of the application that Justin showed earlier, where we have many different image chips. You could imagine expressing that as a set of film strip URLs instead of individual requests. Really, it's an optimization, but it turns out to be a useful one because it means that you can get much more throughput. So just to recap, the 4 different kinds of interactive URL-based requests. You can get a feature collection, so this gives you table data as JSON, KML, CSV. You can get a TIFF from an image. You can get a film strip from an image collection. And then finally, you can just get thumbnail for a particular image. So that's arbitrary projection, being JPEG at, I think it's a pretty generous limit. It's like 10,000 by 10,000 is the largest image that you can extract synchronously like that. Talking about some of the limitations, so I said minutes and megabytes. That's really the scale that you should be thinking for interactive downloads like that. I believe, yeah, our timeout is about 5 minutes, but for an interactive application, there's no way that you want to have someone sitting there waiting for 5 minutes. So as a rule of thumb, I would go for tens of seconds at most. Try to limit the complexity or the size of your result so that it feels performant and feels snappy. The other, yeah, just the size. So I think you're much more likely to run into time limitations before size, but you'll get an error message if you try to export more than, I think it's 10,000 by 10,000 for single image downloads. I don't remember exactly the limits for film strip, but it's all in the documentation. I think it's 40 images at 256 by 256. Does anyone know the limit for table downloads? It might be 5,000. Yeah. But yeah, just filibustering so you have a little more time to type, Sufi. What other, so like Sufi commented, the reason we don't have the ability to run exports in apps is really just because it's mostly an accounting problem. We touched on the fact that apps themselves are kind of like, you can think about them like single Earth Engine users. They are service accounts, and those accounts you can, when you publish an app, we create that account for you in the cloud project that you specify. The complexity there is that a service account, it's like a robot account. It doesn't have a Google Drive account destination. There's no place it can put it. So that automatically kind of knocks out one type of export that we would be able to run. Export to asset is another kind that these service accounts don't have user folders in Earth Engine, so they can't necessarily create assets. It's partially a technical hurdle and partially just and also we I guess more of a policy thing. We want to make it really clear when exports are running, who owns them, and what the limits are, and importantly, like Sufi mentioned, not have a billion tasks running on behalf of people who are not really sure who they are. The last bit is important because apps are available to, or can be available to anyone on the internet, and so the accounting, the who is running this, is just it's not clear.
Okay,
Excellent.
I'm ready.
I really like this setup of like the high level concepts while you're watching the live coding example at the same time.
Yeah, it makes it much easier for me to just focus on the coding and not have to worry about talking to you about what's happening. I could kind of show off what I ended up with if you're ready.
Yep.
So first line, grab the drawing tools. Here I pre-declare all of the widgets that I want to use, and then I declared a function. So this is what I was mentioning earlier about compartmentalizing your code and your callbacks. And what I did was I just wanted to write a function called update label. And all update label did was it takes a URL and it sets the download label's value, which will kind of show the text, and then set URL, which sets the URL. So I just wrote this function update label, and I'm going to use that later. Wherever I need a URL, I know when I call this function, the URL will be placed in the right spot. And then what I did was I wanted to trigger on button click the actual steps that I need to actually get the URL. So on click, what I do is I grab the first layer in my this is called training data. So that returns a geometry layer, but then I want to get the feature collection. So I call layer.getEEObject, and it's a feature collection because if you press when I press this gear icon, I chose feature collection as its setting, and I gave it some properties. You can imagine that could just be like any set of properties. So then I printed the feature collection just to make sure it's like live and up to date, just for my own like debugging insanity. And then I called feature collection dot get download URL. What I asked was I want to get a CSV. There's like a selectors. I just let that undefined. I gave it a file name of CSV, and the last parameter is a callback. And let me just quickly pull this up so you can take a look at what I'm seeing. So the callback it's hidden below the fold here. An optional callback. We always like to use the callbacks because then your code isn't waiting for the feature collection download URL to compute. It'll go and let us know. It'll notify us later when it's complete, and it makes the UI a little faster. But then the callback, it doesn't. Okay, here's a problem with the documentation. It doesn't exactly tell us what's returned, but we're just gonna assume it's gonna be our URL. So you know that's a to-do for us to go and document what our callbacks are gonna return. But I'm gonna just pass in update label because I know we're gonna get the URL, and I know the thing I want to happen is to do that. So I just passed an update label right here. And then last but not least, I created a panel, added a button, added the label, and added it to the map. So then I hit run, download geometries, and there we go. Here is the URL. I click it, and what you don't see on your screen is I get a little download URL. And then I also got a list of features, and there are apparently 11 here. And let me just prove to you that it's live. I noticed that there's a lot of weird shifty things happening here on the UI, and I'm not entirely sure why. So that's something that we'll need to explore later. But I'm going to just add a few more points here. Hit this again. And then now you'll notice that there are now 15 of them. And the reason why is this call to layers.getZero is fetching the live geometry layer that we're adding to. And so when we call getEEObject, we're actually getting the live values of the geometry layer that we're going to return as a feature collection. So this is actually why callbacks are interesting, is because the callback will call when the user is finished doing something, and we can actually use the drawing tools to get the live values at the time in which the user has clicked. And so that's why we use callbacks. And it's kind of another one of those things where you kind of have to think about things not in a non-linear way, because the code isn't executing, line by line by line. Now it's like this little block of code is actually running only when the user clicks. So that's like one of the tricky things that, going back to what we were talking about callbacks and why it's kind of hard to use. But that's kind of also part of the fun of writing good callbacks. So I don't know. I guess that's a very engineer-y way to
I think of it as choose your own adventure. That's what we're programming for. Those little books that we had as kids. All right.
I love
Thanks
this.
for that great discussion on the different ways that we can get information out of Earth Engine, even if we're not exporting it. I think my conclusion that I'd like to convey to people is like, don't download Africa through your browser. Go for another approach. But also earlier, Michael had interesting example of tiles that were already generated that are available at URLs, and an app can expose that if you know exactly what a user might want to download in bulk. All right, let's go back to the next one we have is a live question. Is there a simple way to clear the console, I assume they mean the code editor console, by clicking on a button? Is that something we have?
I can take this one.
Okay.
No. It's a fine feature request. We don't have that. We use the console to print warnings and errors. So we'd have to think a bit about the security implications of kind of being able to hide things in the console programmatically. If you're just looking for a button, you can hit reset, but that will clear your console in addition to also clearing everything else. Yeah, of course, if you're building an app and you are kind of spinning your own console, so you have a UI panel that includes layers, that includes labels, labels and text areas, and obviously you can control that and clear that out. But we don't have a programmatic way or a mechanism in the code editor for folks to do that. But it's a good feature request. I'll consider that one.
Excellent. Thanks. The next question that we have, we've touched on parts of this already in our discussions, but just best practices on how do you make performant apps. We have mentioned already evaluate as a way to get good performance, but other ideas and best practices for making performant apps. Michael, would you like to jump on that one?
Sure. Yeah. So we've already touched on parts. I mean, so the high level idea for writing performant anything is that there's not a lot of useful stuff in my code editor right now. I was seeing if we could actually do any fancy things to clear that. At a high level, it's you can trade computation time for space. So if you have more storage, if you write something to disk, you don't have to recompute it on the fly, and you can save time. That trade-off is just like kind of fundamental to computing, and it shows up for Earth Engine apps as well. Any place where you can pre-compute, like Tyler was mentioning, you know, if you want to serve up a bunch of downloadable tiles, rather than having those be on-fly computed downloads, you know, zip files that are streamed from the Earth Engine service. If you put them on Google Cloud, they will serve faster, and it's just a URL that a user can click. So pre-computing is kind of one theme. Another theme I would say is writing callbacks whenever you can, and chaining things together using the event handling system, and importantly, making sure that things are asynchronous. So asynchronicity is that property that we talked about where you are never waiting explicitly for a result. A good example of something that isn't asynchronous is the get info call. So if you're writing an app and you find yourself using get info, go back because you're doing the wrong thing. Really try to lean on evaluate. So evaluate takes, and the distinction is that evaluate has that callback for when it's finished. So that lets the browser do other things like let users click in multiple places, drag the map around, etc. It can put the request, sort of wait in the background rather than waiting in the foreground and pausing everything else, because that's really the trade-off that's being made there. So we have exporting or writing data out and chaining together callbacks. I guess another design goal would be to have to try to do the minimal thing possible for an application. So it's very high level and generic, but really trying, if a user is going to preview some data, for example, you want to show a thumbnail or an image chip, don't fetch a 10,000 by 10,000 image and then try to squeeze it into a small thumbnail window. Just fetch the data that are relevant or that you need or that you can compute quickly. So that's a design goal. I'm trying to think of other things. Yeah, do other folks want to jump in with stuff I'm missing? I know there are other useful things to do.
Yeah, Michael, you'd mentioned pre-computing and cloud storage layers, and I think that's a really powerful feature. And I have a real quick example, Dusty, if I could share my screen. So this is showing an air pollution plume time series. And if you'll see, there are hundreds of layers. And if you were to compute these on the fly, it's just not going to happen. But we've pre-computed all of these time series images, and you can really quickly run through every layer, because they're pre-computed coming from cloud storage. And if you zoom out, I'm going to hit sort of the limitations of the browser, but you can watch how quickly these all load. So, keep an eye on the gray bars here. And so it's loading these hundreds of layers really, really quickly. So take advantage of cloud storage and pre-computed layers, definitely.
Another thing that we don't talk that much about, but absolutely influences the performance of an app is caching. So when users show up to Earth Engine, they have requests that are the same as requests that were made earlier. So for example, if I'm looking at a layer that someone else has already looked at, often results will be cached. And what that means is we've served the tiles and we hang on to them for a little bit just in case someone asks for them again. Usually that person is you, just refreshing the page or rerunning something. But you do get benefits if you can route users to particular views or locations or zoom levels where you've already pre-computed tiles. So that's sort of the quick and dirty way of getting some value out of pre-computation. But definitely cloud storage layers are the way to go. This is like a technical flex to show off just the amount of data that are streaming through to the client. Super cool demo, Justin.
Yeah, thanks, Saul. I guess one thing that was touched on there that is important is like keeping your app simple can make it fast because you're more likely to hit that cache. If you're giving a user a lot of controls, sliders, things where they can select buttons, that might be very valuable, but it's less likely that somebody's going to hit a cached result if they have a lot of ways to change the algorithm itself. All right. Let's go back to the list of questions. Here's a good one. Is the script code for an Earth Engine app live? Meaning if I change the script for an app or any of the modules that a script depends on, what happens to the Earth Engine app that's already been published?
I could take that one, actually. Yeah, so it'd be nice to actually walk through what happens when you hit publish, when you go to publish an app. So when you hit publish, when you publish an app, what we do is we actually take a snapshot of the code that you see on the code editor. If you actually supplied a script repo, then we take a snapshot of the script repo. And then what we also do is we look at all the require statements in your code. So requires that you pull in modules from other scripts, so you can supply a script. It's a really nice feature. But we take a snapshot of all of that, and we collect all that code, and we make sure that's the code that is going to get run on your app. And if you make any further changes to your code, it won't change your app at all. Even if there are changes in the module script, even those get snapshotted. So you don't have to necessarily worry about code essentially becoming like if someone accidentally breaks something downstream, that your app will break. So that's kind of a nice feature that we have here. That will hopefully give you some peace of mind.
Great. A little variation on that question, and this came from a question at an earlier event that Justin and I were running. There was a question about how apps can be used for supporting published research that we didn't talk about because we were talking about the technical details mostly of building an app. But a key part of apps is that you can actually change the code after it has been published. You can republish and update the app, retaining the same URL. So that can be advantageous if you need to fix bugs, new data arrives, et cetera, in order to replicate the analysis. But it's a little bit different than a strict reproducibility that it's running the exact same code when the paper was published. So we focus more on actually making the algorithms usable so you can replicate the work. But it's still important to actually store all that data from a paper in a repository, whereas there is a static record of at the time it was published. But anyway, that was just a little variation on being aware of Earth Engine apps and how they change or don't change over time. You're in control of it.
Yep. I forgot to mention. I forgot to mention that you can republish apps. Yeah. So when you go to republish the app, then we do the snapshot thing again. So yeah.
Yep. All right. We only have about 5 minutes left, but luckily we've got through all of the questions that were asked that were app related. But we have a few more that were proposed that aren't necessarily about apps, but I'm going to ask a few of them just because we have a few remaining minutes here at the end here. So let's try to keep these high levels and short answers if we can, and we'll try to get through a few of them in these 5 minutes. The first one is, how do you set and use properties on feature collections? That's a more generic one, I guess. One of the major data types of Earth Engine. What is the correct way to set and use properties?
I can take a stab at that. There are actually, when we talk about feature collections are just kind of the table data structure in Earth Engine. There are actually two places where we can meaningfully talk about properties, and it's confusing. Feature collections themselves can have properties. So like the same way that an image has properties, it's an object and it has properties, and there's also a bunch of pixel data. The same kind of structure applies to feature collections. So the feature collection itself can have properties and it has a bunch of features. The way that you can just set and get those just like any other Earth Engine object. The way that you can set properties on the individual features is kind of the other dimension there. So all of those features themselves have properties, and to manipulate those, you map over the feature collection. So we have a function called featureCollection.map, which itself takes a function that accepts an input feature and outputs an output feature. And so you can think about it's a term from computer science, this process of mapping. It's used in a lot of places. It's unfortunate that it collides with all the other maps that we talk about day to day. But what you can do is map over that feature collection, and for each input, you produce one output. And those outputs you can then set and manipulate and compute on the fly new properties for all of those. So when we talk about having I refer to them as like synthetic feature collections. These are feature collections which only sort of exist on the fly. They're not saved anywhere. Those are the result of mapping a function which transforms feature ABC to feature DEF with new computed properties, different geometries potentially. An example of this is like mapping over, and for each for each geometry in a feature collection. So features, let's say they only have geometries. We can write a function that we map over each of the inputs, which takes that geometry, computes its area, and returns a feature that has the geometry and now a new property called area. So those are the two ways in which features can be set on feature collections.
All right. I have one last question that I'm going to ask here, related to apps again. How can you create an app that only certain people can see rather than everybody? Sufi, do you want to take that one?
Yeah, of course. Yeah, so why would you want only certain people to be able to see your app is actually a first good question to ask. So like, for example, you're building like a machine learning classification and you want your training data to be kind of secret, but you want to share your results with your colleagues and you don't want the rest of the world to know about this training data. So what could you do? So what we're going to do is when we go to publish an app, we're going to check that checkbox that says make this app restricted. What you do is what you get to do is enter a Google group, and you can go to like googlegroup.google.com, I believe. And that will let you create a Google group and add people to that Google group. I think they do have to have a Gmail account in order for that to work. But what will happen is when you go to publish the app, when the user goes to that app link, they will see a login page. They'll have to log into a Google account. And if that Google account belongs to that Google group, then they'll be able to enter the app. And so take into consideration that after that point, it's like all the same things as you get with apps. So, for example, we don't necessarily, you'll be able to, view the stuff that's going on the screen. Like, you can look at, maybe the scripts and then all those sort of things. Also take into consideration here, if we're looking at specific assets, we need to make sure that you save the asset. Sorry about that. You make sure to share the asset with the app. And the reason why is you want to make sure that only that app has access to the asset, or whoever else needs to collaborate on it. But this will allow the asset to be viewable in the app. So yeah, it's a new feature that came out fairly recently. So please use that one and let us know if it works for you.
Great, thanks. And thank you all, because we're at the end of the session for today, and we hope you in the audience have enjoyed our Hey EE, How Do I Apps Edition events, and that this was helpful for getting your questions answered. We apologize if we couldn't get to all of your questions. We tried to answer as many as we could, but you can always go to our help support page and use the various channels there for asking questions that didn't get answered here. And we will have additional events like this on topics, parts of Earth Engine in the future. So yeah, reach out to us on the Developers Forum, GIS Stack Exchange, and the other resources that are listed on our help page. If you enjoyed this event or you didn't, we'd love to hear your feedback and suggest what we can do the same or change for next time. So we are going to be sending out a post-event feedback survey form. It'll be short, but just allows you to comment on the event and help us to adapt it to make it even more useful in the future. We really do listen and value your thoughts, take them into consideration when we're rolling out new events. And finally, I'd like to do a big thank you to the team for helping out in this event, the experts that joined us here, folks behind the scenes that are actually helping to put this together as well. And we hope to see you again soon. And don't forget to sign up for similar events like this and others that you see in the Earth Outreach on Air channel. So take care. Thanks.